Jai Hind everyone. Myself Dr. Aditya Pratap Singh from IT department, Ajay Kumar Garg Engineering College, Ghaziabad. Today we are going to discuss a very good topic in the C programming language. Normally you have studied for creating a collection of some kind of data like age of persons, like marks of students, height of students. So such kind of data can be collected in the form of arrays. I hope you have already studied the arrays. We have already discussed in another lecture also. Now today we are going to discuss a collection which is not having the homogeneous data, rather it is having heterogeneous data. For creating a heterogeneous data collection, C provides us a facility in the form of structures and unions. So let's try to understand what is a structure. As far as the definition is concerned, a structure is basically a user defined data type which can be considered as a template used for defining a collection of variables under a single name. That means we are creating or we are combining multiple type of data members inside a single entity that will be created as a structure. So it can help developer to group elements of different data types which are heterogeneous in nature, not necessarily to be of same type, into a single logical unit. Like in the arrays we were creating collection for homogeneous data type. So let's try to understand, like if I want to talk about a book, so what kind of data a book can have refer, like name of the author and the price of the book, number of pages. So if we want to create a collection of such thing, then we can refer to structures. So here, like an example, the keyword we will use to create a structure is struct. This keyword we will use to create a structure in the form like structure name and different members of the structure, then closing braces. And one thing you need to emphasize is that in case of structure we have semicolon here after closing it. In previous, like in functions and all, we have only closing braces, but in case of structure we would require semicolon at the end of the structure. So like for the previous example which we have written for book, so if I want to write a structure for book, then I can write struct book, and we can create the members what we require. Like we require a name of the author, so we can create author name, we can have price using float type, float price. We can have integer type, number of pages. So we can create structure like this also. We can create a structure like struct using struct only. I am having one int roll number and one character name. So here I have not given the name of the structure. In this you can see I have not given the name of the structure. So this structure will be created. This is only used to create a template. Nothing is going in the memory. Memory will be occupied only when this kind of variables will be created. So if we want to use this structure if I want to use this structure, then I need a name. So for that purpose, we can provide a name, like here we have given book. So we can use the struct keyword to create a structure, and followed by a name or the tag for that structure, and we will define what kind of members it is having. So for another example, like struct student, so this is what? This is the tag name for this structure, and we have one name, roll number, branch and year. These kind of data members we are having in this structure student, and at this time no memory will be allocated. This is only what? This is only template, or only a structure given, but no kind of data has been stored into the memory at this point of time. If we want to create variable for such structure, then we can use struct student, the name of the structure. So struct student S1, this is the variable of the struct student type data structure, and slist, it is the array of struct student type structure. So what we have done, we have created a new data type. So this combined can be called a user defined data type. So we have created a new type, we have created a new data type of type student, and here we can create a collection of data for our students. So here like something to remember, when you first define a structure in a file, the statement simply tells the compiler that this structure exists, but it causes no memory allocation. Please emphasize, it causes no memory allocation. Only a structure variable is declared, then only the memory allocation will take place. That means when we define this, no memory will be allocated, but when we define this, the memory will be allocated. How much memory will be allocated? Equivalent to the combination of or collection of all the members. Like in this case, 30 bytes are required for first, second will require 4 bytes, then 20 bytes, and then 4 bytes. So total 58 bytes will be allocated whenever this will be created. So it will require 58 bytes into the memory. So how much size structure variable will require in the memory? Equivalent to its data members. Now different ways for declaring a structure variable. We can declare structure variable in multiple ways. Like declaring a structure is the similar thing, like struct date, these are the data members, and one thing is we are declaring a member here only. We are declaring a member today. So this today is the name of the structure variable. The date is the structure and today is the name of variable which we have created. So we can create a variable just after closing bracket and between the semicolon. So like for example, which we were trying struct book, which we have created earlier, and we were having some data members, and I can create book 1 comma book 2 semicolon. So what we have done, we have created two variables of type book. So this is the one way of creating variable for a structure. Another way is like this structure is similar, but rather than creating at the time of declaration of structure, what we are doing, we are creating later that can be defined inside the main or outside the main. If we want to make it a global variable, then we will create it outside the main. If we want to create it local variable, then we will create it inside the main. Then what we need to do, we need to specify the whole new type. So this is a new type, struct date, and we have created a variable today. So this is the second way of doing this. First way was we were creating here only. Second is we can create later. First we declare the structure and then we declare a variable separately inside the main or outside the main. Another way of doing, like here we have created multiple variables. We can create multiple variables separated by comma. So that can we can also do in this way. Now how to initialize this structure? When we declare a structure, nothing is required, no memory is required. But when we create a variable for it, we need to initialize it or to allocate data to it. So whenever a memory is not allocated for uninitialized variable, so we can initialize this structure variable in different ways. First, declare and initialize in the same statement. So what we have done, we have declared a structure student, and we created a variable s1, and we provided the values for its members, or we can say we are declaring a variable as well as initializing it. Declaration and initialization both are being done in here. So we have provided name for this and roll number for roll number and marks. So we have provided the values which will be stored somewhere into the memory. What will happen? We are having, like when we declare int x, what happens? X is stored somewhere into the memory, like for some location 1004, x equals 10 I have assigned. So 10 will be stored. This is the x. It is stored somewhere. Now when we declare a variable like this one, s1 is declared. So s1 will be given memory. What it require? It requires 20 bytes for name, and it require 4 bytes for roll number, and it requires 4 bytes for marks. And this combined, this whole memory area is occupied by s1. Okay. So total 28 bytes are required. Name will be stored in the name section. Roll number will be stored in the roll number section, that is 1002, and marks will be stored 98.3. And this whole combined will be treated as a structure variable. So what we have done, we have combined 3 different kind of members into a single entity, that is called s1, and this s1 is of type struct student. So we can initialize like this. Another way of declaring and initializing multiple variables. So what we can do, here we are having one student data separated by comma, and then another student data closing bracket and semicolon. Here we have closed the declaration and initialization of structure. So n number of variables you can declare separated by comma. This thing you need to remember, that if you are going to declare multiple variables while declaring a structure, then you need to separate them using comma operator. Now third is initializing a single member. This you can also do. You have declared multiple member in a structure, but you have given data for a single member only. For like here in this example, struct student is created. There are 3 members, marks 1, marks 2 and marks 3, and I have created one variable of type subject 1, and we have given only one data instead of 3 data members. So though there are 3 member of structures, but what is happening, only one is initialized. Then what will happen to the remaining 2 data members? So whenever we these 2 data members are initialized with 0. So if there are variables of other data type, then they will be initialized with the values like integer will be defined as 0, float will be defined as 0.0 and character will be defined as null values. What you need to remember here, or the point to be noted here, that if no member is initialized, then what will happen? Garbage value. Then garbage values will remain there. But if at least one member is initialized, then what will happen? Then the value which is initialized will be taken, remaining will be 0 or their default values. These are the default values which will be assigned. So point here, the important point is what? Whenever we are initializing a member of structure, the variable members will be initialized. If no member is initialized, then there will be garbage value. If any one member is initialized, then all the members will be initialized to 0, or we can initialize all the members by ourselves. We can initialize them inside the main also. Here this is declared, no member is created here. We have created a member inside the main, and we have given values. So this is another way of initializing members of structure. So these are the different ways of declaring and initializing a structure. What is some important note, like structure members cannot be initialized with the declaration. Like here in this example, what we have done, struct point we have declared and int x equal to 0, int y equal to 0. What I tried to give a default value, but it will provide a compiler error. Why it will give a compiler error? The reason for this error is simple, that here is the only declaration of structure. So structure declaration is only giving a template. Template means nothing concrete has been created, only a model has been presented, or only a blueprint has been given that what kind of variable it will create. So here we are just telling the compiler that there will be a type point which will be having 2 integer data members, but nothing has been reserved in the memory. If nothing has been reserved in the memory, then in that situation we cannot provide any kind of value to it, where that value will be stored. So in this situation, what is going to happen? This value cannot be stored anywhere, so it will give compile error. I hope you understand it properly, that until unless memory is provided, we cannot provide any value. Some other important points related to structure. that individual members can be ordinary variables, they can be pointers, they can be arrays, or even they can be another structure. Like for example, we can create a struct address, and we are having int flat number, like char society, like char city, and we can have another, like here we have declared struct person. So what we can have char name, we can have int Aadhaar number, and we can have what we can have struct address A. So what we are going to happen, what is happening here, we are creating a address type variable inside another structure. So this is itself a structure. So what I am saying, one structure may contain ordinary variables, they may contain pointers, they may contain arrays, and they can even contain variable of another structure. These members within a particular structure must be distinct from one another. Same type of member we cannot provide, like we were doing in case of local variables. The member can be same as name of a variable defined outside the structure, because they have been confined inside a boundary of structure. So these variable can be similar. Like here we have used a name. So this name we can provide inside main also, main int id char name, and what we can have struct person p. So what is happening here, we are having one name variable inside p and we are having one name variable in the main. So that is possible because this name is inside the boundary of person or confined inside the structure person. So that is possible. So this is the meaning of this, that one member name can be same as the name of variable defined outside the structure. Once a structure has been defined, the individual structure type variable can only be declared then. Once its template is defined, once its blueprint is given, then we can create the variable of that type. Each member in a structure can be accessed with the operator dot. So dot operator can be used to access the member of structure variable. Like here we have created struct student s1, and if we want to check the name, s1 dot name, if we want to check the roll number of this type, so as an array variable we can do this. So these we can access the member of structure using dot operator. So here is an example of showing this the same thing, how we can declare and access a structure variable. So here we have created a structure point and we have taken two variables, x coordinate and y coordinate. In the main we have created a point p1, initialized it with 0 and 1. Now if I want to change the value, we can have like this, p1 dot x equals 20. That means we are accessing the x member of p1 variable. And if we want to print, we can print like p1 dot x, p1 dot y. So it will give output 20 and 1 because we have initialized x with 20 after initializing it with 0, and y is still 1. So y will be printed 1. So I hope you have got the point how to access the member of a structure variable. So in normal situation, we access structure variable using dot operator. Now let's try to understand how they are being stored inside the memory. Memory में क्या हो रहा है? Memory is having like here in this example we are having a structure book having name, float, price and int pages. I have deliberately taken name as a normal character, but actually it should be taken as a array character array, but here we have taken this only. So whenever we will create this B1, what will happen in the memory? How much memory will be occupied? Char will require 1 byte, float will require 4 byte, int will require 4 byte. So total 5 bytes will be reserved. 1 byte is here, name given B, and next 655.192, 655.2223. So this price is stored, and next 4 bytes these pages are stored. So 4 bytes and 1 byte. So this combined will be treated as a structure. Whenever B1 will be accessed, all the data is available with B1. Another way for structure declaration using TYPEDEF. What TYPEDEF is a facility provided by the C to create an alias. So we can declare this as a TYPEDEF struct student. So this now here, this is not a variable, This is what? This is the name of this type. We have defined a type. TYPEDEF means we are defining a type. So we have defined a type, this complete thing, and we have given name to this type is stud. So stud is now alias name or another name for this struct student construct. So here but the variable declaration will be like stud record. So what we can use int main, and we can directly create stud record like this, rather than writing struct student record. So this we cannot, we can use this, or we can use like this also. So another program for TYPEDEF. So this is the complete program for this. Here we have created stud as a TYPEDEF, and we created a stud record, and now record ID is 1. We have named record name is Jatin, record percentage is this, and we can use we can print them record.id, record.name and record.percentage. So this line has been changed with the use of TYPEDEF. TYPEDEF is used to create a alias for something. It is not a preprocessor directive. Rather than it is just giving information to the compiler as the another name of something. It does not occupy any memory. We can create pointers also, pointers of type structure. Like here, this point is a structure, and we have created struct point P1, and we have created struct point pointer P2. And we assigned the address of P1 to P2. This is what? Address of P1 to P2. So we have created a pointer of type structure. So in case if we want to give the pointer variable, then the accessing of variables or accessing of member will be different. In this situation, previously what we were using dot operator for accessing. Now we will use arrow operator rather than dot. With pointer we need to use, you can see here, P2 arrow X, P2 arrow Y. They will be used for accessing the member variable. So this is how you can perform using structures in the C programming language. You can create the arrays also, like a normal variable. You can create the array and you can utilize using the index of the array 0.x, array 1.x, array 5.x. So these can be utilized with array, but they will be treated as normal variable and dot will be used. If you will create specifically a pointer, then arrow operator will be used. So thank you all. In the next lecture, I'll cover the topic union. So that's all for today. Thank you.